Section 3 is entitled Beginning Proofs. 2-column proofs. So you start off with things that are given and something that you want to prove. And suppose we are given the following. Angle 1 is a right angle. And angle 2 is a right angle. And of course, we're going to try to prove that angle 1 is congruent to angle 2. Congruent means that the angles have the same measurements. Two 30-degree angles are congruent to one another because they both measure 30 degrees. So now here we have statement or statements, and we have reasons. How we spell reasons correctly. We have a statement and the reason that statement is valid. Statement 1. Angle 1 is a right angle. Angle 2 is a right angle. I could have listed that as statement 1 and statement 2. I just chose not to. In fact, let's just do that. Statement 1 and statement 2. Well, statement 1 is true. The reason it's true, because it was given to be true. We were told angle 1 is a right angle. And we were given that angle 2 is a right angle. Now I say that angle 1 is congruent. That just means equal to. Is congruent to angle 2. And the reason is not given, but the reason is all right angles are congruent to one another. Congruent. All right angles are congruent to one another. Just like all 30-degree angles are congruent to one another. Right angles is just another way of saying 90-degree angle. All 90-degree angles are congruent to one another. So very simple proof. Statement, reason, 2-column proof. Suppose you're given something like this. A, B, C, D, E, F, G. And you're given the following. You're given the diagram, and you want to prove that angle AGD is congruent to angle EGD. And we'll do this on the left, on the right. You have statements and you have reasons. Statement and reasons. Well, the first thing is you're given the diagram. And the reason is it's given. And 2, that angle AGD is a straight angle. A straight angle is an angle that's 180 degrees. AGD is a straight angle. And number 3 is the same thing for EGD. EGD is a straight angle. 2 and 3. Now, why is AGD a straight angle? And the reason is, when you go from A to D in a straight line, you cross G. G is on the line segment AD. G is on it. Doesn't matter. I mean, if I draw a line and I line A to D and I put G anywhere line segment AD, given or draw line segment AD. If you put G anywhere there, then that angle is 180 degrees. It's the straight angle. Basically, if you pick G and you go to D and you go to A, but nonetheless it's a straight line, then that's 180 degrees. It's a straight angle. Okay. Now, why is EGD a straight angle? Because G is on, I meant above to say the line segment, G is on line segment ED. It's on the line segment ED. So angle G, or also known as EGD, is a straight angle. Now for number 4, you can say angle EGD is congruent to angle AGD. And the reason is all straight angles are congruent. They're equal to one another. They all equal 180 degrees. Okay. So very, very basic proofs. Just to give you a slight introduction to doing geometric proofs via two-column type proofs. Okay. Suppose you were told this. Suppose that you are given this figure. You are given a figure like this. Angle 1, angle 2, angle 3. A, B, C, D, and E. And you're given the diagram. You're also given that angle 1 is, say, 25 degrees. Angle 2 is 45 degrees. Let's put the degree symbol. And angle 3 is 20 degrees. And you want to prove, although our picture doesn't look like it, you want to prove that angle BAE is a right angle. before I would get involved in this, is I would want to see what BAE is. You start at B, you go to A, and then you go to E. It's that big angle. The sum of the parts make up the whole. Angle 1 plus angle 2 plus angle 3, that's the whole angle. You know what? When you add those three numbers, if I didn't add them up or pick them incorrectly, they will add up to 90 degrees. Okay, so proof. Excuse me. So statement and reasons. Statement 1 is the diagram. And that's given. Because just because these three angles add up to 90, that's enough. That's not enough. You have to argue that those three angles make up BAE. And if you don't have that diagram, you can't do that. Number 2, angle 1 is 25 degrees. Statement 3 is angle 2 is 45 degrees. And statement 4 is angle 3 is 20 degrees. And each of these last three are given. In fact, the first 4 were given. Now you say statement 5. Angle 1 plus angle 2 plus angle 3 is equal to 90 degrees. Now, for your reason, I don't know, arithmetic. For arithmetic, I added addition. Addition. I added addition. Now, number 6. Angle BAE is equal to angle 1 plus angle 2 plus angle 3. Sum of parts equal the whole. Sum of the parts equals the whole. Now, we have what I just boxed equaling two things. What I have boxed, that is angle 1 plus angle 2 plus angle 3, equals 90, and it also equals BAE. So I'm now going to say angle BAE is 90 degrees. And the reason is if two things are equal to a common thing, if these two things are equal to a common thing, namely angle 1 plus angle 2 plus angle 3, then they equal one another. If two quantities equals a third quantity, I'm going to come to the top, please. Then the two quantities are equal to one another. And think about it. If you take a test and you get the same grade as Shirley, and your other friend gets the same grade as Shirley, didn't you two get the same grade? If two quantities of your grade and your friend grades, those two quantities equal a third grade, namely Shirley's grade on her last geometry test, well then your grades are equal. Right. Now, the next statement, because we still haven't said that BAE is a right angle, and that's what I want to say. The next statement, call it number 8, is angle BAE is a right angle. Now, what What was the last thing we said about angle BAE? We said it's 90 degrees. So why is BAE a right angle? All 90-degree angles, by definition, are right angles. What was the definition of a right angle? It's 90 degrees. All 90-degree angles, including angle BAE, is a right angle. So there's the proof why BAE is a right angle. The sum of the parts equal the whole. You eat part of a pizza pie now, you eat some more later. Tomorrow you eat the rest of it. In total, you ate all of it. Suppose you have this. Suppose you're given that angle ABD is 10 degrees. ABD is 10 degrees. ABC is 100. Angle ABC is 100 degrees. EFY is 70 degrees 20 minutes. Angle EFY 70 degrees 20 minutes. 20 minutes is a part of an angle. It's part of a degree. 20 minutes, denoted by 1 prime, is part of an angle. There are 60 degrees equal 1 degree. 60 minutes is equal to 1 degree. Okay. Well, this is a third of 60. So equal a third of a degree. Now, how can we see that more easily? We multiply by 1. Doesn't matter if they look equal or not. If two quantities are equal, when you divide them, you get 1. 1 degree and 60 minutes are equal to one another. When you divide them, you get 1. Just like 2 days, or let me not get more advanced, 1 day and 24 hours. They really are equal to one another. You divide them, you get 1. Now, what happens here is, first let's make the degree symbol look more like a degree symbol. First thing is minute divided by minute cancels out, and 20 goes into 60 3 times. So you have 1 over 3, and the units are degrees. 20 minutes is a third of a degree. You have part of a degree. I figured I'd throw that in. And XFY, angle XFY, going to be 19 degrees and say 40 minutes. And that's the given. Let's write down what we want to prove and then go ahead and prove it. I'm going to prove that angle DBC is congruent to XFE. XFE. Angle XFE. So, it looks to me, oh, why didn't this come out? Proof. Sorry about that. Now, it looks to me like we're going to have 2 different diagrams. We know that ABD and ABC, they look like they both have A and B. So here's A, and for argument's sake, there's B. Now C would say B here. Now, ABC looks more than 90 degrees. In fact, if I just would come up there, then that angle would be 90. So we're 10 degrees more, 100. And then you say, oh my, that's exactly what ABD is. Turns out that ABD is there. How far you go out to put A and D and C, that's up to you. But there's your picture. There's your picture. Now, I notice in the next graph, in the next two angles, when I add them up, I get 89 degrees and 60 minutes. But 60 minutes is a full degree. 89 degrees and 60 minutes is 90 degrees. So, it seems like I have this right angle. And F seems to be in the middle. Now, you have EFY. E, go to F and go to Y. Here's Y. This angle is 70 degrees, 20 minutes. And X, F, Y, that's the balance of the 90 degrees. It's 19 degrees, 40 minutes. Okay. So now, what we're being asked to show is that XFE. XFE. Oh, the 90 degree angle is the same as angle DBC. DBC. Oh, the 90 degree angle. And we need to prove that. So, whether the diagram was given or not, you could come up with it. So basically, the whole strategy to prove this is to prove that those two angles, DBC and XFE, are right angles. And once we show that they're right angles, we can say they're equal to one another. So that's the whole strategy. I want to show that they're right angles, and since I need some more space, I'm going to put the given underneath given. Angle EFY is 70 degrees, 20 minutes, and angle XFY is 19 degrees and 40 minutes. I still want to prove the right angles at the bottom. I want to prove that those two angles are right, and then I'll just say, yep, they're congruent. Once I have that these two angles are both right angles, then I can say they're congruent. All right angles are congruent. Okay, so statement and reasons. The first statement, I'm going to stop writing this every time, but that's the first statement, the givens. Reason, they're given. Okay. Number 2. Angle ABC minus angle ABB is equal to 90 degrees. This was 100 degrees, and this was 10 degrees. Reason? 100 degrees minus 10 degrees is 90 degrees. I don't know how else to say that. Okay. Now, due to lack of space, I'm going to rewrite what we have to prove on the bottom. DBE is congruent to XFE. And one of the reasons you have to write down the givens is because how did I know that that was 100 degrees? Because I wrote it down. Somehow that didn't get recorded. Angle ABC was given to be 100 degrees. So that's part of the given. And ABD was 10 degrees. Number 3. Angle ABC minus angle ABD is equal to, let me make sure I do this right, minus ABD is equal to angle DBC. Now, the reason for this, I'm at a loss. I mean, but basically all I did was subtract. I had angle ABC, and I took away this little piece here. That is, I took away angle ABD, and I am left with angle DBC. Subtraction of angles. Subtraction of angles. Right. You subtract part of an angle, you're left with the remaining part. You subtract part of an angle, you're left with the remaining of the angle. All right. Now, once again, I have this, and notice the subtraction sign in between, and I have this. They're the same. On one hand, it equals 90 degrees, and on the other hand, it equals angle DBC. So statement number 4 is going to be angle DBC equals 90 degrees. And reason number 4 is going to be, again, if two quantities equal a third quantity, then the two quantities are equal. If two quantities equal a third quantity, then the two quantities are equal. So right now, I have angle DBC. Oops. Okay, so this must be a typo, XFE. This is a typo on the bottom. When I transposed it, I wrote it down wrong. Okay. So right now, we have that's a right angle. Excuse me, that's 90 degrees. That's 90 degrees. So due to lack of space, I'm going to erase these 4 statements and reasons, and I'm going to start over with number 5. It's a brand new problem almost, except we're still allowed to use the givens from step 1. It's a brand new problem, and what I want to do is now show that that's a right angle. Now remember, I stated that I made these 2 statements. I made those 2 statements. So now I'm going to say that angle EFY plus angle XFY is equal to 90 degrees. EFY and XFY is 90 degrees. The reason is 70 degrees, 20 minutes, plus 19 degrees, 40 minutes is equal to 90 degrees. All right. Now I have both of these angles on the bottom equal to 90 degrees. Number 6. Angle DBC is congruent to angle XFE. All 90-degree angles are congruent. So yes, those two angles are congruent to one another because they both equal 90 degrees. So before you try to do a proof, you have to kind of foretell the future. You have to see the future. You have to see, oh, those two angles that they're asking me to prove congruent are both 90-degree angles. So let me prove that the 90-degree angles, and then I'll say they're congruent, because all 90-degree angles are congruent to one another. Okay. Suppose you are given this figure. Points A, B, C. You have this line, and you have two angles, 1 and 2. You also have these two rays meeting at D. And you are given the following, G for given. You are given that angle 1 is x plus 7 degrees, and that angle 2 is 2x minus 3, and angle ABC is x squared, and that angle D is 5x minus 4, and these are all, of course, in degrees, 5x minus 4 degrees. And you want to prove that angle ABC is equal to angle D. Well, angle ABC, so now I'm going to think it through. ABC, A to B to C. ABC is this big angle, which is angle 1 plus angle 2. So I just want to show that angle 1 plus angle 2 is equal to angle D. Okay. So statement and the reasons. 1 is G. That is, it's all of this. It's all of that. Now some teachers, I remember my high school geometry teacher, allowed me to put all 4 of those statements as statement 1. If your teacher says you have to label them 1, 2, 3, 4, well, he or she is the one grading your papers. Do so. Why am I allowed to make these 4 statements? It was given. Okay. Now, angle 1 plus angle 2 is equal to angle ABC. Sum of the parts is the whole. Sum of parts equal the whole. This comes up so much, just write it in shorthand. The sum of the parts equals the whole. Sum of parts equal the whole. But angle 1 plus angle 2, remember this is angle 1 and this is angle 2, and when I add them up, I get 3x plus 4. 3x plus 4 is equal to x squared. That was given. Angle ABC is x squared. Addition. Now, let me just come to the top and solve this. We know that x squared is 3x plus 4. Now I'm going to use algebra. X squared minus 3x minus 4 is 0. If I factor, I get x minus 4 times x plus 1 is 0. I pick negative 4 and positive 1 because when I multiply those two numbers, I do get negative 4, and when I add those two numbers, I do get negative 3. Well, if this times that is 0, then either this is 0 or that's 0. And you all know that 4 minus 4 is 0. So x is 4. What plus 1 is 0? Negative 1. Those are the two answers. Now, it might be that they make no sense. It might be that they make no sense. For example, if x is 4, then angle 1 would be 4 plus 7 or 11 degrees. That makes sense because it's positive. If you double x, if you double 4, you get 8. You take away 3, you get 5. That makes sense. You square x, 4 times 4 is 16. You multiply x by 5, excuse me. 5 times 4 is 20, minus 4 is 16. And it's not because that angle B equaled angle ABC, it's just that they're positive quantities. Now, if you plug in negative 1 plus 7, why, that's 6. That's okay. 2 times negative 1 is negative 2. You take away 3 more, you get negative 5. That's the problem. An angle can't be negative. An angle can't be negative. 5 times negative 1 is negative 5. Take away 4 more, you get negative 9. So, statement 4 is going to be x is equal to 4 degrees. And I'll call this algebra. I solved the equation in number 3. I solved the equation in number 3. X is 4. All right, x is 4. Well, statement 5. Angle ABC is 4 squared. More algebra. Or if you preferred to go a longer route, if you preferred, you could have said that x squared is 16. Square both sides. You can square both sides of an equation. Okay. Now, somewhere in the given in statement 1, we said that, okay, number 6. 5x minus 4, 16. And this is algebra. 5 times 4 is 20, minus 4 is 16. Okay, now, what I'm going to say next is, and let's see if I already said this. Here. I've already said that this is another way of writing x squared. And I've already said that this is another way of writing x squared. So they're equal to one another. Angle D and angle ABC are equal to one another. And that's all I wanted to show, wasn't it? So, statement 7, if we can read this, let's see. Statement 7 says that angle ABC is congruent to angle D. If two quantities are equal to a third quantity, they're equal to one another. That would be the reason. We already know that that's angle ABC, and we already know that's angle D, and they both equal 16, so they equal one another. They are congruent. If two quantities are equal to a third quantity, they're equal to one another. 7. If two quantities equal a third quantity, then the two, let me come up here please, then the two quantities are equal. Then the two quantities are equal. And that finishes that problem. So there are some elementary proofs that we just did. And I hope you understood this course. This is what the course is going to be from here on, doing geometric proofs or writing up proofs.